All right, let's continue talking about exponent rules. We're going to get into the negative exponents and zero exponents and find out what those look like and how they behave. So we'll work with them and figure out a pattern and rule for those. So let's first off start off by taking a look and evaluating different exponents. So let's take 2 to the n power. It's evaluated to the power of 4. So that's 2 times 2 times 2 times 2, which would be 16. 2 to the third would be 2 times 2 times 2, which is 8. 2 squared, 2 times 2, which is 4. 2 to the first is 2. So taking a look at that, maybe you can see the pattern. Let's start the other one too, 3 to the n. 3 to the fourth would be 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. 3 times 3 times 3 is 27. 3 times 3 is 9. 3 to the first is just 3. So think about that. Can you find that pattern? And then can you extend the pattern? Go ahead and see it, fill in the rest of that table, and then pause the video and restart it when you're ready to check your answers and see if you're right. So those are the values of the exponent for that given value of n. Because the pattern is we're dividing by 2 as we go down our chart. So this has to be 1 if it follows that same pattern. This has to be a half, and a fourth, and an eighth, and 1/16. Because we have 0 2's, 2 to the 0, means we have 0 2's, but 1 is always a factor of everything. 1 times all of these. It's the hidden imaginary factor. And then when we have to negative first power, the negative first power is 1 over 2. So we have 1 times, or 1, actually we're dividing by 2 once. Now we're dividing by 2 twice. Dividing by 2 3 times. We're dividing by 2 4 times. So that negative exponent really means that we're dividing. So we have 1 times nothing. So just 1. 1 divided by 3. 1 divided by 3 divided by 3 again. So anytime you see that negative exponent, it means that we are dividing by the base. 0, power of 0, shows us that anything to the power of 0 is 1, because everything has that factor of 1. So let's get some more of that definition of negative exponents. So let's expand, write out, and see what happens. So 3 squared over 3 to the fourth is 3 times 3. 3 times 3 times 3 times 3. Divide, we get a factor of 1 for those. So we have 1 over 3 times 3. So that would be 1 over 3 squared. And in the next example, we have x times x over x times x times x. Factors of 1, so 1 over x to the first power. And we can rewrite these. 1 over x to the first is the same as x to the negative 1. 1 over 3 squared is the same as 3 to the negative 2, because we're dividing by 3 2 times. Dividing by 3 2 times can be written using the negative exponent. So you've got the definitions down below, but just like negative exponents mean we're dividing. So to make it a positive exponent, you just use that reciprocal. And here's another reason why that 0 exponent works. So 3 to the fourth over 3 to the fourth is 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3. Divide and we get factors of 1. So 1 over 1. 1 divided by 1 is 1. And we've eliminated those exponents. So it's 3 to the power of 0, because the 4's or the 3's canceled out. X to the third is x times x times x over x times x times x. Factors of 1, 1 over 1 is 1, or x 0 times. We lost our variable. So the definition of 0 exponents, a to the 0 power is 1. So try these next examples out, restart the video when you're ready. So 2/3 to the 0 power is 1. This whole thing is raised to 0 power, so I have 0 2/3, but I still have a factor of 1. Negative 8 raised to the negative second power means I'm dividing by negative 8 twice, which gives me 1 divided by negative 8 twice. So 1 over negative 8 squared. Remember, that's in parentheses, so I keep it there. If I want to evaluate it, it'd be 1 over 64. 1 over 2 to the negative third. So I'm dividing by 2 in the denominator. When I divide by 2, it's going to end up meaning I'm multiplying by 2 3 times. Because if I take 1 and divide it by 2, that's what it's going to look like. So 1 over 1/2. And when I simplify that 1, when I'm dividing by 1/2, it's the same as multiplying by the reciprocal. So really, that's why that 2 moves up into the numerator. So I have 2 to the third. 2 times 2 times 2 is 8. Negative 1 to the 0 power is 1. So now let's put it all together. Let's simplify the expressions just like we did last lesson, get rid of parentheses. Each base should appear only once. Evaluate powers with numerical bases. Let's not use any negative exponents. So let's do some more practice up top there. 1 over 4 to the negative third. And so we're dividing by 4, which means it's going to move to the numerator. So it changes floors. Exponents, when they're negative, change floors from bottom to top. So it's really 4 to the third. Negative 2 to the fifth. Times negative 2 to the negative fifth. So then I'm dividing by negative 2 5 times. And then those give me factors of 1. So this equals 1. Negative 3 to the third to the negative second means I'm dividing by 3 to the third 2 times. And when I divide by 3 to the third, it means I have 1 over 3 times 3 times 3 times 3 times 3 times 3. 1 over 3 to the sixth power. And 3 to the sixth power is 729, so it's 1 over 729. And finally, 6 to the negative second over 6 to the fourth. That base is raised to a negative, so I'm going to divide by that one, so I still have a 1 on top, so 6 times 6 on the bottom, and 6 to the fourth is still on the bottom. So 1 over 6 times 6 times 6 times 6 times 6 times 6, and 6 to the sixth power is 46,656. And I ran out of space. So 1 over 46,656 in its simplest form. So why don't you try those next two examples? Check your answer when you're ready. Okay, so 4x to the negative second times y to the fourth over 8x to the sixth. So this x to the negative second means I'm dividing by x twice, so I can move that down to the bottom. I can expand out y to the fourth and y to the sixth. I divide out my y's, so I'm left with 4 over 8 x to the third y squared. I'm going to divide 4 and 8 both by 4 to give me 1 and 2. So I have 1 over 2x to the third y squared. You can also use those rules that you learned. So if I have y to the fourth over y to the sixth, I know that I can subtract those exponents when I'm taking the quotient of powers. So I can subtract 6 minus 4, and I have 2 y's on the bottom. x1 plus x squared gives me x to the third. Next one, we have 12x to the eighth over y to the negative seventh, which will mean I'm dividing by 7, or y 7 times, so I can put that on the bottom. And then I have 4x to the negative second, y to the negative 6 squared, so that happens twice. And then as I work through it, I know that these x to the negative second and y to the negative 6, those will move up to the numerator. And then I can expand it all out. So 12x to the eighth, another x squared, y to the sixth, and y to the sixth. Or 4 times 4, which is 16y to the 7th. Then my y's cancel out, factors of 1. 12 and 16 can both be divided by 4, so I get 3 and 4. So I have 3 on top with x to the 12th and y to the 1, 2, 3, 4, 5, y to the 5th. And I have all my y's cancel out in the bottom, just 4. I did something wrong in the bottom there. This should be like that. So keep that in mind as we're working through that. You might want to use your shortcut rules. So maybe you looked at it right here and said, oh, this is 12x to the, combine my x's, x to the 12th, y to the 12th as well, over 16 y to the 7th. And maybe you subtracted those, y to the 5th. There's no x's to combine. Simplify 12 and 16 as 3/4. So if you're at that point where you don't need to write it out the whole way, you can recognize those rules, go ahead and do that. So we took a look at the negative exponent rules, which means we're dividing. And we know that when we have a negative exponent, we can just change from numerator or to denominator, depending on which level it's on. And we found out that anything raised to 0 power is 1. Do some practice work. If you have questions, we'll take care of that in class.